For thousands of years, mankind used the stars to navigate as they explored and discovered their own world. Now we have created our own constellation of satellites to develop the most sophisticated and accurate navigation system in history. And we need it now more than ever, with more and more of us traveling farther and faster through the skies. At any given time, there are more than 10,000 aircraft flying over the U.S. alone. That number goes up every year.
We need new navigation systems simply because the systems that we have in place right now, some of those are 40+ years old. We will need a global type navigation system that is not tied to these systems on the ground.
Satellite navigation systems are the future of aviation in America and throughout the globe, making the skies safer and enabling performance-based navigation for the next generation air transportation system. The gold standard for satellite navigation is the Global Positioning System, or GPS.
GPS has matured to the point where there are literally hundreds of millions of users worldwide. Virtually every new cell phone you buy today has a GPS positioning and timing receiver included, and many cars include navigation systems. People are depend on it every day and count on it to be there.
For navigation on the ground, GPS is part of our everyday lives. But for navigation in the skies, it has become vital.
Aviation is transitioning to satellite-based technology, and GPS is the cornerstone of that.
GPS has three parts: satellites in orbit, control and monitoring stations on Earth, and GPS receivers that have become ubiquitous around the world, be they in cell phones, in cars, or in airplanes. The signal is usually accurate within 10 to 22 meters.
GPS has been described as one of the greatest innovations for aviation since the invention of the jet engine. For the first time, a single navigation system can enable aircraft to fly from takeoff to landing in the most efficient manner possible. But the FAA requires more performance than that. We need improved integrity, and we need improved accuracy and availability.
As good as GPS is, it can occasionally provide incorrect position information. This is unacceptable for safety-critical aviation operations. So the FAA has developed two systems to supplement GPS. Integral to the next-generation navigation solution is the Wide Area Augmentation System, or WAAS.
WAAS is a satellite-based augmentation system that augments the GPS, and it provides accuracy and integrity to aviation users.
Since its commissioning in 2003, WAAS has proven its benefits to an increasing number of users within its coverage area.
WAAS service expands over the U.S., Canada, and Mexico.
WAAS uses a network of ground stations and geostationary satellites to improve GPS performance to an even greater accuracy. 1 to 2 meters, both horizontal and vertical. And like GPS, it's available in all phases of flight, from departure to arrival, and at every airport within its coverage.
The new technology allows you to begin to change how you operate in the air. You can create these three-dimensional points in space that allows you to fly more directly rather than flying this sort of circuitous route.
And with the WAAS, you can provide that service to any runway without installing any equipment at that location, versus the legacy systems require installation of a significant amount of equipment at every runway end.
A WAAS-based three-dimensional approach, known as Localizer Performance with Vertical, or LPV, can provide the same service as ILS Category 1. However, ILSs are only available at runways where the equipment has been installed. WAAS is available at all runways of all airports under its coverage, without the need for any ground-based hardware. For major airports, WAAS offers enhanced access, helping the busiest hubs stay on schedule. For smaller airports, WAAS opens approaches to runways without instrument landing systems. For business jet companies, WAAS allows private jets to fly a precision approach into small towns and rural areas, as well as the major hubs. Many carriers are benefiting from more reliable access to more locations.
We've been able to provide access to airports for carriers such as Horizon, such as FedEx, NetJets. We are working with them right now to provide LPV capability to areas that they normally would not have access into.
There are plans to improve WAAS and expand its reach to some of the most demanding and critical flights in the skies.
Normally, an EMS provider is doing an unplanned, unscheduled, emergency-type activity.
For emergency medical flights, safety and speed are critical. But helicopters traditionally rely on the same navigation aids and route structures as jets, especially when the weather is poor, so they cannot take the most direct route.
Helicopters had to get into the fixed-wing infrastructure and fly the same routes as jets or other large aircraft.
WAAS enables routes to be created specifically for helicopters, from any one point to another.
WAAS allows us to build a completely different infrastructure only for vertical flight. Now with this infrastructure, they can fly directly to the trauma center. It provides a tremendous life-saving advantage.
Another key system for the future is known as LOS.
The LOS, or Local Area Augmentation System, is intended to be used in the precision approach area of the flight phase.
At a LOS-equipped airport, monitoring stations on the ground collect data from GPS signals and transmit corrected position information via local VHF data broadcast. A receiver on an approaching aircraft translates this into an extremely precise GPS signal, accurate within a meter or less.
The biggest advantages from using the LOS system come from the precision of the signal, the high level of integrity of that signal. The fact that also one system will cover all runway ends at an airport actually reduces the cost, and at the same time is increasing the safety and efficiency of the system.
This is especially attractive to many airlines across the country that are constantly burdened by flight delays.
At an airport, a high-density airport like the ones you typically see in the northeast of the United States, LOS would be a contributor to achieving closely spaced operations so that in the future, when in the presence of bad weather, you'll be able to more consistently perform the operations you're looking, which will translate into more timely operations and cost savings for the operators and for the passengers.
LOS will eventually provide what is known as Category 2-3 service. This means guidance all the way to the runway surface, even when visibility is at 0. Commissioned for use in 2009, LOS is already gaining support from major airlines like Continental, who have begun equipping with LOS technology for both domestic and international advantage.
We are very excited to see that the international community have already become early adopters of the technology. We have received very positive feedback from pilots who are currently using the system, playing up the capability of the signal, playing up the stability of the signal compared to their regularly used ILS service.
We're focusing a great deal of our attention on the satellite-based navigation. However, we are developing and evolving technologies with our ground-based systems as well.
Navigation will always include ground-based systems such as ILS and DME. And lighting systems will continue to play a key role, as they have since the early days of aviation.
Lighting systems provide pilots a visual cue to quickly and positively identify the runway environment. They provide that extra margin of safety to approaching pilots.
One innovation in lighting is elegant in its simplicity, changing the light bulbs.
The typical lifespan of an incandescent lamp is around 2,000 hours. For LEDs, it's 50,000 hours. In other words, you can replace the old incandescent lamp and forget about it.
With a much longer life and more consistent color temperature, LEDs will become the new beacon of safety on approach. As the next generation systems move forward, existing ground-based navigation aids, including DME and ILS, will be maintained and enhanced to ensure a smooth transition.
Those systems will serve as backup systems to satellite-based systems.
The existing infrastructure has always been safe, but as costs go up, we have to figure out how to do the same thing as safe or safer than we do today.
In any transition from one system to another, there will always be the legacy piece of it. The planning and the operation, the function of that legacy system is just as important as the new system that you'll bring on board.
Global aviation is changing. The FAA wants to ensure that the United States continues to be at the leading edge of these changes. New satellite-based systems like WAAS, LOS, and GPS, combined with enhancements to existing navigational aids, are taking us into a new age of performance-based navigation. An age that promises more consistent flight patterns, fewer delays, less congestion, more cost efficiency, and above all, a safer way to fly.
Future navigation is focused on the transition to satellite-based systems. They provide better capability at a cheaper cost and with more benefits to the customers.
It has revolutionized the entire way aviation is going to be conducted in the future. It is a new era in a new century.
I'm definitely very excited to see where this technology is going.
When I go into the field and I talk to both pilots and controllers, I can feel their excitement about what's coming, and we're really excited to be at the center of that energy.